Alright, so on number 9, I have 4z to the third plus 8z squared minus 9z minus 18. So 4 terms. There's no GCF here, because I have a 4 and 8, a 9 and 18, so no GCF. I have 4 terms, so I want to look at grouping. So if we factor by grouping, what can I factor out of the first 2 parts? 4z squared. So in doing that, I'm left with z, squared, there we go. 4z plus 2. So then z plus 2 should be back here. What's going to fill in my hole there? Minus 9. So then, once I get there, what's on the outside? 4z squared minus 9 and z plus 2 there. What? Am I done? No, why not?
Because you can square.
Difference of 2 squares in the front. That is denoted by the yellow highlighter. So then if we factor out the difference of 2 squares, 2z plus 3, 2z minus 3, and then just the z plus 2. Well, come on with it. All right, then we have 27 into the third plus 1. 2 terms, so we really only have 3 options. There's no GCF between 27 and 1. So, is it a sum or a difference? Sum. So really we only have one option, right? So the only option is going to be sum of 2 squares. So remember, if we have the sum of 2 squares, we're going to have like a to the third plus b to the third. We go with our formula of a plus b, because the signs match, and then we square the first term, we change the sign, we multiply those 2 values, and then we do b squared. So this part has to be a perfect square. What's the cube root of 27n to the third? 3n plus, what is the cube root of 1? 1. So now we're basically done with our original part of the problem. Now we're just really going to use these 2 values right here. So I'm going to take the first term and I'm going to square it. So what's 3n squared? 9n squared minus, now I want to multiply those 2. So minus 3n, and then square the last term. So 1 squared is still 1. So we're adding some soap to the problem, like that. So it's same. So same sign. Opposite sign. Okay. So So fresh and so clean. All right. Number 10. Do we have a GCF in this one? Yes, we do. It is m squared. So that leaves me with 36 m to the fourth plus 12 m squared plus 1. So first things first, check to see, it's a trinomial, so check it to see if it's a special case. So if we know that it's a perfect square, we don't. Okay? We may know that it is going to be a perfect square. Again, you may not. Okay, that's okay. If you're not sure if it's a perfect square, then you can always just go to your diamond or your X or your Red Bull that is going to give us wings right here. So, first term, 36 and 1 multiplied together is 36. Middle term is 12. So, let's get our wings. Two numbers that multiply together to give me 36 and combine to give me a positive 12. 6 and 6, right? So, again, if you're not sure, 36 m to the fourth plus 6m squared plus 6m squared plus 1. So we just traded those two out. Whatever that term is, that middle term is, it's going to match those middle terms there. Okay, I'm going to kind of do this part and then I'll just tack the m squared that we pulled out at the beginning. So I'm just going to do it by grouping. What can I factor out of 36m to the fourth and 6m squared? 6m squared. 6m squared plus 1. Whatever goes in that one is going to go in my other one. 6m squared plus 1. Looky what we have here. It matches. Whoop, wrong arrow to the wrong spot. So plus 1. So then factored is just 6m squared plus 1 and 6m squared plus 1 again, and don't forget the m squared that we had in front. Now we could also rewrite this as m squared times 6m squared plus 1 quantity squared. I would take either of those two answers. So 14 is one of those kind of funky problems because you have two different parts. You have two different variables, but you have the three that kind of go together. So basically I want to factor, I don't have to move anything around because it's already kind of set up, and then just the 36 or the negative 36y squared's out to the end. So how am I going to factor x squared minus 10x plus 25? Yeah, x minus 5 squared. So I have x minus 5 quantity squared minus 36y squared. So again, remember, just because it has the parenthesis around the x minus 5 and we have a binomial, this is still just a difference of two squares. Okay, so if it's a difference of two squares, I'm basically going to write the x minus 5 minus 6y. Guess I actually need brackets. And then I'm going to have x minus 5 plus 6y. Now, I'm okay with you dropping off the parentheses if you want. That's completely up to you. I think sometimes just putting the parenthesis around it and understanding that you have one in the first one, you have another one in the second bracket, it kind of helps make it a little bit easier to distinguish that that's kind of its own thing. Okay. Biggest thing is on problems like this, don't overcomplicate it. Just get everything but the a or the y squared or whatever other variable you have. Put everything kind of separated out as a trinomial, and then just whatever's left in this case. Since you can't do it by grouping,